And for our next speaker, one from academia. You have to, yeah, give your. So we ran into Sander when we were looking into automatic text summarization and automatic text generation, or robot journalism, how it's called. And we still have like a request out for. So hopefully, if it's granted, we can employ Sander and one of his fellow PhD students and have them here working for some while on a text summarization project.
That would be nice.
Yeah. And even if we have find more money, then we can also do the text generation. But we'll see if that's something we can start in 2015 as well.
Yeah.
But welcome at Sanoma, and we're looking forward to your talk.
Okay, thank you. Yes, as Sander mentioned, my name is Sander Wubben. I'm from Tilburg University. And in this talk I will talk about automatic summarization and also automatic simplification. So first, a bit about me. Yeah, so I'm Sander Wubben. I'm from Tilburg. You can also see my Twitter account there if you want to follow or whatever. And my interests are in the natural language processing and also natural language generation. So that is indeed text generation, or the more maybe buzzword kind of thing like robot journalism, where you actually have data, and from the data you can actually generate texts. And of course you can add a lot of value by making text out of the raw data that for a lot of users doesn't really have any meaning. So yeah, natural language generation, you can see it as a subfield of natural language processing, and natural language processing is basically everything. It has everything to do with dealing with texts. So processing text, so understanding text, working with text, anything you can think of. So I recently also started a company which is called Readably, which also does these kind of things. So really the application-based things of natural language generation. So really building applications where we generate language. So in this talk I will briefly tell you something about summarization. So I don't really know what your background is and how much knowledge you have of natural language processing or natural language generation. Has anyone ever heard of natural language processing up until now? Yeah? Okay, so you are quite familiar with it. Okay, that's good. So I will, for summarization, I will just briefly talk you over really the basics of summarization. So how can you build a summarization system yourself? So just getting some really basic components and just building something. And summarization is basically, I mean, you probably all know it, it's generating a shorter version of a text. The idea is that the text is shorter, but you still have all the main important things in there. And I think it's more relevant than ever now. So of course it's always been something that's important, but now we really see there's a lot of information overload. There's so many web pages, so many applications that want to have your information, that want to send you information. But you can't really read everything. You can't read all these pages of text. You quickly want to see what's happening. You quickly want to have the relevant information. So that ties in with mobile devices. Of course, you have a lot of, well, you have a smaller space basically, right? You don't have a big screen. You have a small screen, and you want all the information on there. So if you have less space and the same information, you need to summarize. So there's not much time to get a message across. So you need to have the important things there. And also simplification, which is the second subject I'll be talking about, is related to summarization, but it's not really the same. So in simplification, we try to generate an easier text, a more readable text. So it doesn't really have to be a shorter text, but it does need to be more easy to comprehend, more easy to understand. And again, this holds the same thing holds. If you have an information overload, you want to read something that doesn't take a lot of time to process, so you want to have easy text. And also, if you look at the demographics for certain user groups, it's getting harder and harder to follow information. For instance, elderly people or people with reading disabilities or people who are actually starting to learn a language, you really want to have easier language for them. So there's lots of interest in summarization, as I mentioned. Companies are also recognizing what's happening. So there was this guy, actually, the left one. He was a high school student, and he made this app, Sumly, and he sold it for I don't know how many, but a lot of money, lots of millions of pounds to Yahoo. And Yahoo then made this Yahoo News Digest, which is really an app that gives you just every day, it gives you some stories, it gives you all the important information in one app, and you can read it in like a minute, and you have all the important things at your disposal. So yeah, the summarization is really hot and happening, I guess. So I will really talk about some basics of summarization and how you can write your own summarization system in 5 minutes. Maybe you can even do it in Excel, I don't know, but you can at least do it in Python. So the idea of such a summarizer is as follows. So we do extractive summarization. So extractive summarization is we have a text, we select some pieces of the text, and we make a summary. So usually humans use actually abstractive summarization. So if you've seen a movie and I ask you, okay, what was it about? You will not give me specific lines of dialogue from the movie. You will make your own story, right? You will sort of make your own summarization, and you will use your own words. So that's different from using extractive summarization, where you use parts of the source text. And for machines, it's of course a lot easier to use extractive summarization, because now we only have to select some of the parts of the text. But the problem is we need to know how to select those sentences. So which sentences are actually relevant? Which sentences are important? So how do we do that? Well, we look at the words. So I want to do a small experiment. I don't know if you know it, but I will show you a sentence on the next slide for a few seconds, and I want you to count the number of F's in the sentence. So just a few seconds. Read the sentence, try to understand what the sentence means, and try to read the F's, okay? Just 3 seconds. Okay, here we go. 1, 2, 3. Okay. So how many F's did you count? 3. So who said 0? Let's start at 0. No one? 1? 2? Yeah? 3? Okay, the majority thinks 3. 4, 5, 6, 7. Well, the right answer is actually 6. So finished files are the result of years of scientific study combined with the experience of years. And you see that the F's that you probably missed are the F's of the offs here. Result of years of scientific study combined with the experience of years. So these words, of words, apparently we don't really recognize them because we don't even see the F's in there. So back to weighting words, this gives us one clue already. So apparently words like of are not really important to us. So maybe they are also, when we write a summary, these words are also not important. And that's actually true because if you think about word weighting, you think probably about how many times a word occurs in a text. So you might say, okay, suppose there's a text about cats. Well, we say, okay, if the word cat appears in the text, we give it a 1. If it doesn't appear, a 0, right? So it either occurs or not. But that's not really a good weighting because some texts might be really about cats and some might be about dogs, and they mention cat once. So maybe we want to count how many times cat appears in a document, right? If it appears 10 times, it's more about cats than if it appears once. But we also want to know, and that's actually the trick, in how many documents does the word occur? So the word cat will not appear in every document because it only appears in documents about cats. But words like of or the or they will probably occur in every document. So they might occur a lot in a document, but they are actually not important for the document because they occur in every document, right? And that's actually how we weight words. So we look at how many times does it occur in the document and how many times does it occur in all the documents. And that's what we call TF-IDF. So TF is the term frequency, DF is the document frequency, and we inverse that because once it occurs in a lot of documents, we actually want to give it a low weight. So that's IDF, the inverse document frequency. So here's an example. Suppose we have a cat, which appears 3 times in the document. We have the word of, it appears 20 times in the document. So now the term frequency, if the document is 100 words, of cat is 0.03, and of it's 0.2. So now we see that of has a higher weight, but it's not really an important word, so that's not what we want. So then we look at all the documents, and we see that cat appears in only 1 of 1,000, of appears in almost all the documents. So now we take the logarithm of this inverse document frequency, and we see that we get 3 for cat and 0.05 for of. And if we then multiply that, you see that of, or sorry, it says but it should be of. Of has only 0.001 and cat has 0.09. So you see that cat gets a higher weight. So that briefly is the idea behind weighting the words. So this is what you see. You see that there's some stop words, so like of the they have a very high occurrence and they have very low value actually. And we have rare words, well, the very specific words, well, which have a very high value. They don't occur a lot. So these are very specific for a text. So we can use this in the vector space model, and that's where we actually represent all the documents in sort of a space. And the idea is that we see a document as a collection of words. We call this the bag of words model, so we just throw in all the words in a document in a bag, and this is what we work with. And we can actually represent the document as a vector, so as an arrow in space, and we take each word as a dimension. So, and then the score for each word is sort of the score on that dimension. And then if we have these vectors for documents, we can actually calculate how similar they are, how close they are, right? So this is what it looks like for 3 words, bank, money, and bad. So if we have 1 sentence about banks and money, 1 about banks and bad, and 1 about money and bad, for instance. And you can just calculate the angle between these vectors. So now we can actually build a summarizer, because if we use this principle, we can say, okay, we want to have a word, we want to have sentences that are most similar to the document, so that are most representative to the document. So these are the things that we need then for a summarizer. We need to find a way to split the sentences, so to make sure that we know this is a sentence and this is a sentence, which are words and which are like question marks and periods. And the trick is that we then regard the text as a collection of documents, and we regard the sentences as a document. So instead of that we say the document is the document, we see it as a collection of sentences. And the trick is then to find the number 3, 5, 7 sentences that are most similar to the document by using these TF, IDF, and the vector space model. So here's the code, but it's probably a bit small. Okay, so I'll just briefly go over the code for anyone interested. So it's Python, and we use a few packages. We used NLTK, the natural language toolkit, which has a lot of things dealing with natural language. And we have SaKE11, which does some things like calculating TF-IDF, so you don't have to do it yourself. You can do it yourself, but this is easier. And we just have a function which calculates the scores, the TF-IDF scores, and we have a function which makes the summary. So it splits the sentences using NLTK. Again, you can program it yourself, but it's already incorporated in NLTK. So it splits sentences, it splits words, it lower cases everything so that you that if something has a capital in it, it's regarded the same as when it doesn't. And basically, you can now just score each sentence regarding similarity to the document and just pick the 3 most similar or the 5 or whatever. So this is in short how it works. So this is 60 lines of code. So suppose we run this and we put some text in it, you will see that it just selects some of the sentences. So I just picked the text about some hostage situation in Sydney, and apparently Uber managed to ask really high prices for rides getting away from this situation, and they got a lot of problems with it. And this summarizer gives back the 3 most representative sentences. And you can read that, actually if you read these 3 sentences, you already get a pretty good idea about what this article is about. So this is something you can read on your app, and it gives you some idea. And this is like 60 lines of code, right? Really simple. So this is basically what I wanted to show you regarding the basics of summarization. The second part that I want to talk about is simplification of sentences. So now we did it on the, we regarded the entire article and tried to summarize it, and now I'm going to look at sentences, specific on the sentence level. So this is part of text-to-text generation, and there's lots of tasks that you can do. Sentence compression is one, paraphrasing, question answering, or simplification. So in this part I'll talk about simplification. So this is the task. We have a sentence which might be difficult to comprehend or whatever. We want to generate a simpler sentence. And again, the content should be roughly the same. The meaning should be the same, but it should be more readable. And this is often helpful for news because everyone should be able to understand the news, but often the language used is way too complicated. So how can we do this? Well, we know that we have a source sentence and we want to generate a target sentence. And there is a technique that you can use that we probably all use. And I'll get to that in a minute. So sentence simplification is really about making text more accessible by changing some of the structure of it. So it can be useful for language learner, people with reading disabilities, etc. So in my experiment or in my PhD work, I built the system PBMTR, which it's called, and I compare it to the state of the art in simplification. And this is how it works in a basic form. So I regard this as a machine translation task. So if you probably all know Google Translate, you probably all use it, and this is, well, Google Translate does the same thing. It takes a source sentence and transforms it into a target sentence. The trick is, of course, that Google Translate does to Dutch or German to Spanish or whatever, whereas this is, for instance, Dutch to Dutch or English to English, but complicated English to simple English. So I used machine translation. So PBMT stands for phrase-based machine translation. So it operates on phrases, so not only on words, but on larger parts of sentences. And what you typically need if you make such a system is a monolingual parallel text for monolingual applications, which means basically that machine translation systems, they learn from examples. So we already saw some examples of machine learning. Machine translation is a form of machine learning. So you give in some data and it learns from that. So we previously saw something about classifiers. Machine translation it works a bit different. You give it a text and you give the translation and it learns to translate it, basically. So what you need to feed into this algorithm is examples of, for instance, Dutch sentences and English translations, and then it learns to translate in English. So for our experiments or our work, we used English text, complicated English text, and simple English text. So how does machine translation work? So in the early days of machine translation, it was basically rule-based. So there was a dictionary, there were some rules, how you would translate English into Dutch, for instance. And that's how these systems worked. But a few years ago, like 15 years ago, 10 years ago, statistical methods were becoming more popular, and they are now the state of the art. Google Translate also uses statistical models. And they learn from examples. And we actually also learn from examples. So what you see here is a Chinese menu with English translations. And actually I don't speak any Chinese, I don't know if you do, but we can actually figure out some of the words and their meanings by looking at co-occurrence. So for instance, the word wonton, every time it occurs, also this character occurs. And that character only occurs when wonton. So we can sort of deduce that probably this character means wonton. And there are some others, so we have chicken. And if chicken occurs, a lot of the times, or maybe always, this other character occurs. So maybe that character means chicken. Now here we see that we have a character which occurs sometimes. So mostly when soup occurs. But here it's actually missing, because here it's, I guess, translated as mix. And here we have soup, but we don't have that character. But we can still say, okay, in like 8 of the 10 cases, it occurs. So the probability is very high that this word is a translation for soup. And that's how statistical machine translation works. It calculates probabilities of translations, and then it combines them into one translation model. So where do you get your data? Translation systems, of course, you have to have multilingual data. One of the sources is, for instance, subtitles. So they are there in lots of different languages, and you can align them on the second, because you know when subtitles appear in languages. So that's one thing they use. They also use the proceedings of the European Parliament. They're all in every language translated, so you can use that. So that's for machine translation in different languages. If you want to do simplification, we use English data, and we use Wikipedia, the encyclopedia we all use, I guess, and simple English Wikipedia, which is a simpler version of Wikipedia with shorter, more basic articles. So it consists of 100,000 sentence pairs, and we can, sorry?
SBS pairs.
Yeah, exactly. So we train on 100,000 sentences, and then we evaluate how our method is working. So we compare to the state of the art. These are these two systems, this one, and to a sort of a baseline where we only substitute words. And we did some human evaluation in a lab environment, and they had to rate sentences on their simplicity, their fluency, so how grammatical they were, and adequacy. So if the meaning was still the same. So these are the automatic results. So bleu is actually an automatic score, which sort of gives you an indication how much your translation is like a human translation. So simple Wikipedia scores 1 because it's exactly the same as simple Wikipedia. And our system doesn't work that well, I guess. It's 0.38, no, sorry, yeah. Well, 0.43, it actually does work. It does work well. But if you look at Flash Kincaid, it doesn't work that well. Lower scores are better, and we actually have a high score. And this is the formula for this automatic measure, which is basically a measure that tells you how readable your text is by calculating words per sentence, syllables per word. And when we looked at human evaluation, we actually saw that our system In the case of simplicity, it scored as well as the state of the art, but actually it scored higher in terms of adequacy. So it scored higher in terms of meaning. So we actually beat the state of the art, so that's really cool. So that's some indication that this approach actually works in simplifying texts. So here are some correlations. I'll skip that. How much time do I still have? None? Okay, I'll wrap up then. I'll skip this. So I want to briefly mention this application that I'm working on. So this is an application that tries to simplify press releases. So this is a project in cooperation with ANP, the Dutch press agency. And they really want to focus on writing more readable press releases. Their chief editors are not always happy with how their journalists write, so they really want to have a tool that actually checks it for them. It does some very simple things. It checks for length of sentences, for frequency of words. And I want to actually implement the system that I just showed you to recommend simplifications for sentences. So I will briefly show you what it looks like. Okay, so I'll just take this text from nuke.nl about rhinos, which we saw in a previous presentation. Some very basic analytics about your text. So it tells you about how many high frequent words are there. It gives you sort of a distribution about, okay, most sentences are like 10 words long. Most words are like 4 characters long. And they have some style guide, and it checks actually for this style guide if your sentences and your paragraphs are okay. So here it highlights the sentences that are not okay. And in the future, there will be this recommendation component here which shows you what to make simpler and how. Okay, so that's basically what I wanted to tell you. So I've shown you something about compression, summarization, simplification. I hope you got a bit of an idea how these systems work and how you can actually use them. So thanks.
Really amazing. Questions? Tessa?
Summarization, you basically pick the sentences that you start out to say. Have you thought them going forward and actually construct a sentence which is even better than an individual from the article? When they write a long article, sentence structure is different than you would do for a really summarize.
Yeah. So of course I need to mention that this is really basic, really the basic system. So of course there's lots of research that has gone really beyond that, using graph structure and all kinds of other things. But what you say is actually very challenging. So just picking sentences and just displaying them, that's pretty easy. But once you actually try to construct sentences, that's a lot harder actually, because you need to take into account that you generate well-formed sentences. So I've also, this approach that I showed you for simplification, I also used it for compression of sentences to actually create abstractive summaries, but it didn't really turn out to work that well. The best way was still to just delete words from a sentence and then form new sentences. But yeah, it's a hard problem.
But it's something that's being sort of studied.
Yeah. So there are studies, but it's still the case that most summarization is really like this, like extractive, picking stuff from the text and generating a new text. Yeah.
Ryan?
How often can you summarize text?
Okay, so that's a good question. How often can you summarize a summarized text? Well, of course, there's a certain amount of information in a text, and the more you try to summarize, the more you lose. So it's really about how much information do you want to keep in your summary, I guess.
When you keep summarizing it, will it end up being 42 as the last?
Yeah. You'll just get the number. Yeah.
Very strong.
Last question about Dirk?
Yeah, could you also use the information in external corpora or domain-specific knowledge to improve the summarization, especially the sentence selection, for example?
I guess so, but in what way would you do that?
Well, if something is a really technical subject, then maybe the words that occur that are technical in your text are more common in this subject. So maybe they're less good to do as selection for sentencing or something.
Yeah. So if you want to really look at external corpora for summarization, I think actually if you use TF-IDF on these corpora, you will actually get another distribution, but you will get a distribution specific for that domain. So, for instance, certain terms that don't occur really often in normal language, in that subdomain they might occur a lot, so they might get a lower weight, for instance. Yeah.
So dildo will be filtered out for the FIFA.
Yeah.
Okay.
Definitely.
One more question from Arne?
Yeah, I was wondering about the symbol with P, is that also in Dutch?
No, but I guess you can make it if you want.
Yeah, well, I had to write very large.
Yeah.
And I was wondering then what data set did you use for this copy-paste from your
So yeah, so it's not implemented there yet. So then actually I will use news articles and do another selection, because there really isn't a source for Dutch. Yeah.
Do you know the company Wise Notes? Coincidentally?
Yeah, I do.
Because they're auto-summarizing, or they're doing a test with nu.nl at this moment, I believe.
Okay. Yeah. So I read about a proposal that they actually submitted also against simplification. Yeah.
Okay. Well, another round of applause for Sander.